Welcome to this fast-paced Terraform for Beginners course. This course is designed to be completed in just over an hour, but it will provide you with a comprehensive introduction to Terraform and its capabilities. By the end of this course, you'll have a solid understanding of the benefits of infrastructure as code, as well as how Terraform works. You'll be able to use Terraform to manage and provision your infrastructure. During this course, you'll learn about Terraform's basic syntax and usage, as well as how to use it to create and manage infrastructure on Docker and AWS. You'll also learn about best practices for using Terraform. By the end of this course, you'll have the skills necessary to use Terraform to create, manage, and version control your infrastructure in a consistent and efficient way. This will not only save you time and effort, but also help you to avoid errors and ensure that your infrastructure is always in the desired state. So whether you're a developer, system administrator, or DevOps engineer, this course will help you to take your infrastructure management skills to the next level. It will also make your job easier and more efficient. Finally, if you find that you need more of an in-depth course, you can check out my Terraform 101 Certified Terraform Associate course, which has more than 10 hours of video content. Well, that's it for now. Let's get started with this course. Let's start with the agenda for this course. What is infrastructure as code, or IAC? We'll spend some time over that, talking about the benefits and the advantages. Then we're going to focus on Terraform, why Terraform, what problem does it solve, and then we're going to have a section on the hands-on of Terraform. So we're going to run Terraform in a lab. We're going to have two examples, a Docker example and an AWS example. All right, so what is infrastructure as code? Well, infrastructure as code is the process of managing and provisioning infrastructure with machine-readable definition files. So think of it as an executable documentation, if you will. Some of the advantages of infrastructure as code: it provides configuration consistency and standardization for deployments. It is simple to learn and write, as it is more like configuration than development code. It allows you to turn manual tasks into simple automated deployments. You can create reusable modules for easy sharing and collaboration. You can modify existing infrastructure safely by using a dry run before applying changes. You can integrate with current application CI/CD workflow pipelines for more mature automated deployments. It creates a blueprint for your environment. It is consistent, repeatable, idempotent, and predictable. It allows you to create or recreate an application's infrastructure for disaster recovery. Terraform overview. Terraform is an immutable and declarative provisioning language based on HashiCorp's configuration language, HCL for short, or optionally you can use JSON. It is written in the Golang programming language. You can use it for a consistent workflow to provision and manage all your infrastructure on-prem or in the cloud throughout its lifecycle. Terraform can manage low-level components like compute, storage, and networking resources, as well as high-level components like DNS entries and SaaS features. Terraform is designed to work with almost any infrastructure that provides an API. So Terraform, through the API, talks to AWS, for example. Terraform is a stateful application. State is a necessary requirement for Terraform to function. State is kind of a database that allows Terraform to map its configuration to the real world. Terraform is a cloud-agnostic tool, public or private, and therefore isn't limited to a single cloud provider, such as AWS CloudFormation or Azure Resource Manager. Terraform allows IT organizations to focus on learning a single tool for deploying its infrastructure, regardless of what platform it's being deployed on. So it really is a multi-cloud deployment platform. So what are other tools out there? So you've probably seen Chef, Puppet, Ansible, PowerShell scripts, Bash scripts. However, these tools work well for configuring the operating system and preparing that operating system to host the application. They're not really purpose-built for provisioning infrastructure in general and cloud infrastructure in particular, and also platform services. So some native cloud provisioning tools are also available. These are also infrastructure as code tools, and each cloud has its own YAML or JSON-based provisioning tool. Terraform can be used across all major cloud providers and VM hypervisors. So it's kind of a lingua franca, if you will. You learn it once, you learn the syntax once, and then you can use it with different providers. All right, so let's get started with the hands-on lab. And we're going to start with lecture 1 and talk about the basic commands in Terraform. Okay, so we would go to our GitHub repo, and first thing we want to do is run a code space. So you can go to the GitHub repo and click the code button, and from here you can create a code space on main. You can also fork this repo into your own repo and do the same thing, run code space on main. Either way works. You don't really need full control over the GitHub repo, so just running code space should be fine. This will take a few minutes and then we will be ready to go. I'll pause the video in the meantime till we're ready. Alright, so our environment is up and running. Excellent. So as you can see here, we have a number of folders and each one corresponds to a lecture that we're going to go through. So you can see here from 01 all the way to 09, and today and for this lecture we're going to talk about basic commands. So if you open this folder and you look here, there is one file called main.tf, and .tf is the Terraform configuration extension for any of its files. And if you open main.tf, this is our main file that Terraform is going to use to execute. And it's broken into a number of block sections. The first one is a Terraform block section where we define providers. And as we saw before, providers are plugins into the Terraform core to be able to use it to extend or to basically talk to the APIs of the different providers out there. In this case, we're going to talk to Docker. So here we have a Docker provider, and this is the source for it and the version that we're using. And it's always a good practice to pin the version just in case in the future somebody else uses your code. It will work and it will not go and default to the latest version and might have some breaking points in the code that will not work. Now the next block here is called the provider block. It depends on the provider. Sometimes you need to execute or put some options here, but in this case for the Docker provider we don't need to, so we just leave it as is like that. Then we come to a number of resource blocks. In this case we have 2 resource blocks, and think of a resource block as a way to create a resource or provision a resource. In this case the first element of the resource block is the type. So in this case it's Docker_image, and then we give it an arbitrary name, any name you'd like to name it. In this case it's engine_image. So here this is fixed, you can't change that, and this one you can change, give it whatever name you want. And then every resource has some options to choose from. In this case the name for our Docker image is nginx : and the tag for that image. The next resource is the Docker container resource, which allows us to create a container. And in this case, the arbitrary name we're giving it is nginx_container. And the name of this container, we're going to call it web-server. And the image we're pulling is the previous image we just pulled. So the resource Docker_image pulls an image into your local Docker deployment or install. And then we call that image using this option here, image docker_image.nginximage.imageid. So notice when we're referencing some other resource, we just use the type, which is the Docker image right here, followed by a dot, followed by the name, which is the nginx underscore image, followed by an attribute that this particular resource has. And this attribute is the image underscore ID. All this would be shown in the actual documentation, which I'll show you in just a little bit. Then we want to expose some ports. So the internal port for the container is port 80. We're going to expose it to our host machine on port 8080. Okay. So that's basically all it takes for us to pull an image and run a Docker container. Now, let's run a few commands to get this all working. So first of all, let's change our directory into the basic commands directory. From here, our first command to learn on the CLI is Terraform init. And what Terraform init does, it initializes our Terraform folder here, and you can see it says initializing the backend, initializes provider plugins, so the cruise worker Docker, I can't really say the name very well, and version is matching 3.0.1, which is right here, so it's pulling that provider into our folder here, and it tells you Terraform has been successfully initialized. And notice what happens, it created a .terraform folder with the provider that we have here, and a bunch of code that you can see here. There's the binary for that particular provider, so that won't open up because it is a binary. All right, looks great. So now let's move on to our next command. And also it created this lock file, which we will look and understand a little bit more in the next lecture. Now let's move on to the next command, and this one is Terraform format. Now, Terraform format will clean up our code. So I intentionally put some extra spaces here, maybe a space here to make it look not as neat and tidy. So when you write Terraform format here, it's going to go ahead and look through the entire configuration files within your folder and clean it up to make it look a lot nicer. So you can see the tabs and the spaces are all fixed and looks a lot nicer that way. So that's Terraform format. The next one is Terraform validate. So let's make something here. Let's make an error somehow and say, instead of name NAM, and type Terraform validate. And when you do that, you're going to get an error message, missing required argument. Argument name is required. And it sometimes even gives you a hint. Did you mean name with an E here? And certainly that's what we meant. So back to line 17, put an E. And notice in GitHub code spaces, I don't need to hit Control S to save. It automatically saves my files for me, which is really neat. And let's run again Terraform validate. And this time it successfully validates our configuration. So the syntax looks good. Let's go ahead and move to the next command, which is Terraform plan. And what Terraform plan does, it goes through our entire configuration and gives you a dry run of what Terraform is about to provision. In this case, you can see that, let's make this bigger. When we ran the command, it went through the configuration. Anything with a green plus sign means it's going to create. So the first thing is going to create a Docker container, nginx container, and it has a bunch of things it will create, as you can see, attach, bridge, command, and health checks if we had any labels, ports. Here are the ports that we just specified. And then also the image we're pulling, the Docker underscore image, and you can see the name of the image as well. In total, or finally as a summary, it tells you the plan will create 2 resources, 0 to change, 0 to destroy. And that's it really. It's a dry run. You could save this dry run into a file and then run the next command, Terraform apply, or an easier way for us is we're just going to run the next command, which is Terraform apply. And what Terraform apply does, it will run a plan ahead of the apply, and it's the same plan we saw before, but then it gives you a prompt asking you, do you want to continue? We say yes, and that will go ahead and create our resources, our Docker image, and our Docker container for us. So we give it a second or two, that gets created. It gives you apply complete, resources to added. I'll even have the port exposed already. I can open this in a browser, and there we go. We will see our nginx default page show up just momentarily, and here we go. Successful. We have been able to we're using Terraform, create a Docker or pull a Docker image and create a container out of it, expose the proper ports. Everything works very, very well. And if you notice, after this is done, a new file gets created called Terraform state, and we will discuss what this Terraform state file along with the Terraform log file in our next lecture. So the final command we are going to go through is Terraform destroy. And that, as the name implies, it will go ahead and destroy our infrastructure that we just created. Before we destroy that, let me run Docker PS for you just to show you the container running. As you can see, it's running right here with the exposed ports. And the web server is the name of the container as we saw in the configuration. If you run Docker images, you'll also see the Nginx image as well. So now let's run Terraform destroy. And what it does, similar to Terraform apply, it's going to create a plan for us. And in this plan, we see that it's going to destroy two resources, the Docker image here and also the Docker container as well. So it will run the plan and then ask you whether you want to go ahead and destroy this or not. You have to type yes to do so. That will destroy our environment for us. All right, so that is it for this lecture, and I will see you in the next one. Let's now take a look at the lock and state files. So we're back in our repo here, and we are in lecture 2, so lock and state files. And if you notice, if we go to main.tf, it is exactly the same file that we saw before. So let's change directory into this particular folder, and once again initialize our folder with Terraform. So Terraform initialized, and I'm going to show you a way to deploy this with Terraform apply and a flag called auto approve. Now this flag is pretty dangerous and not to be used in production because it doesn't prompt you whether you want to deploy or not. It's just going to go ahead and auto approve the deployment. Now where would you use this? You use this in a CI/CD pipeline, and in that pipeline you would have a peer review before you push into production, and that will go and deploy for you. But again, you have to have the review ahead of time. Once again, this has created our container for us, and you see Nginx running. So all looks good. All I need to focus on in this lecture really is two files. The lock file here, and what this lock file does, it locks the version of the providers that we're working with. So remember, the provider we're working with here is the Docker provider, and this is the source of it, and the version is 3.0.1. So the purpose of the lock file is to make sure we don't shoot ourselves in the foot later down the road, and maybe this provider has now version 3.0.2, and we don't want to have somebody else who's using our code use a newer version that might actually not work with what we have here. So that's the purpose of the lock file. It will sit here in the repo with us, and there's no harm in having it here. The next one is the Terraform state file. Now this is a sensitive file, and that's why you see it's grayed out here, because in my .git ignore you'll see all the state files are ignored when we're pushing into GitHub. Okay, so that's important. Also, the .terraform folder, as you can see, is also not to be pushed into GitHub. Okay, so back to our state file. The reason why is that there can be sensitive information, and we'll see in just a few lectures one example of that. And as you can see here, it really keeps track of the state of our infrastructure. So if we scroll down, you can see outputs. We don't have any outputs here. Resources, we've got a couple of resources. So the first resource is mentioned here, which is the Docker container. And the name of it is Nginx container, as we saw. And it keeps track of a bunch of things. Every one of these resources has an ID and so on. So you can see all the different parameters. You can see the ports used, the external, the internal ports. And the second resource is that Docker image that we mentioned. Also has an ID and has some parameters and options as well. So this is important when we are keeping track. It's a Terraform is a stateful application, which is amazing because now we can keep track of what has been deployed in the real world through the state file, so you can add more to your resources, remove some, and so on. All right, so I just want to show you now that when I destroy this resource or these two resources, the state file is going to get updated as well. So if we run Terraform destroy, and I'm going to cowboy this and say auto approve, again, not to be done in production, but just to speed things along, this will automatically remove our resources, and as you can see, the state file also got updated. Now, I promised in the previous lecture to show you the actual documentation and where I got this and how I implemented this. So let's go ahead and do that. And if you type and see, let's say Docker, actually just to make it easier, let's look up this provider. So let's go here and say Terraform registry and paste this. So the Terraform registry is a place where you can, anybody can create a provider and upload it to this public registry, and other folks can basically use those providers, similar to Docker Hub if you're familiar with Docker Hub. Okay, so we are right in our Docker provider here, and there are some very important things to look at. The first one is how to use this provider. If you click here, it will tell you exactly how to use it. So you can grab this, copy this code, and put it right here. And that's exactly what we have, right? So very simple to start. Now, there's also an example usage that you can work with. Here, one of the parameters for the provider Docker is to use the Unix sock here, but because we're using this locally, we don't have to specify it. It's fine. Here's an example of pulling an image, just like what we were doing, and an example of creating a container. So you can grab some of this code here, the examples, and play around with them, test them out to make sure you know what you're doing. Now, the second thing to look at is on the left-hand side, you would have something called resources and data sources. Data sources we will cover in a later lecture, but resources we saw before. Remember the Docker image and the Docker container? So Docker image, if you click on it, it will give you example usage, Docker image. And remember, this is a keyword that is locked. You can't really make changes, but this one is the name of the resource that is arbitrary that you can change. Here's the Docker image, and here is also the Docker container. And you can look at the different options that are here. The required options are the image and the name to use the container, and some optional parameters as well that you can see here. And at the end, usually, of each one of those is this is quite a lot of options. There is usually a command to show you how to import this. So sometimes you might have resources in your infrastructure that have been deployed outside of Terraform, and you want to import them into Terraform. So this allows you to do that with Terraform import. This is outside the scope of this beginner's course, but you can find it, of course, in my detailed Terraform 101 course. All right, so that is pretty much it for this lecture. We covered what the log file is, what Terraform state file is, and also what to look in the documentation, how to navigate the Terraform registry documentation for your purposes. I'll see you in the next lecture. Now, a very important topic in any language, programming language, is variables. So let's tackle that in this lecture. And let's go back to our code here, our repo, and let's close up all these files. And now we're in 03 Variables, so let's go in and take a look at our file here. And as you can see, let's make this bigger. As you can see, now we have a few blocks here called variable blocks. And these variable blocks have the keyword variable and then a name for this variable, in this case the image underscore name, image tag, internal port, external port. And each one has a type. Now you don't have to put a type or description or default. You can just leave it empty. You can leave it like this, okay? But it is a good practice to give a type for this variable. So in this case, it is a string, so a bunch of letters and numbers. The description for it is also good practice. So this is the name of the Docker image. A reasonable default that you might need. So Nginx is the default in this case. It might not make sense to put an Nginx as a default image. So you can remove this default line, but we'll leave it for now because I want to show you something here. The next one is the image tag. Once again, the type, a description, and in this case 1.23.3. The variable internal port. This is of type number. In this case, it's digits basically, which is port 80. I give it a description, but I did not give it a default. And we'll see what happens when you don't give defaults. Same thing with external port. It's a type of number, and I don't have a default for it. Now, these variables, we need to reference them, right? So in our actual code, you can see our resource, the Docker image. Here we're using something called string interpolation. So if you recall in the previous lectures, our main image had the Docker image resource had the form of nginx : 1.23.3. Now what we're trying to do is we're trying to build that same format, but using variables. So in this case, I use the keyword var dot the name of the variable, which is image underscore name here, separated by a colon, and then once again the $ and the curly braces, var dot image tag, right, which is this. So this all is surrounded by parentheses here, as you can see, double quotes, and these double quotes take any kinds of variables with anything in between. Like I can, instead of a colon, I can put dash, dash, for example. But of course that doesn't make sense. It will give us an error because the container is looking for the proper syntax, which is the name of the image followed by a colon followed by the tag. So that's string interpolation. The next part here, if you don't want, or if you just need to reference a variable such as, in this case, we want the internal and external ports, you can just use var.internal port, var.external port. We don't need to surround those with the $ and the braces or the actual double quotes as well. Terraform will understand this directly, as you can see here. Now, you might not think that this is really that important. I can just write whatever I need here, the image name, the tag, and the external and internal ports. So while this is true for this simple example, but as you start to write a lot of Terraform code, it makes a lot more sense to use variables, because now you can change the variable assignment here and it will change that multiple places in your code, which is really the benefit of having variables in any programming language. So let's see this in action, and let's change our directory to 03 variables. Once again, we need to Terraform initialize this directory since we are working in a new directory. And now let's run a Terraform plan, just to remind you of what a plan does. And notice when you run Terraform plan, it's going to ask you for the external port. Remember here, internal and external ports, we did not define a default. So Terraform has no way to figure out what port we want or what number we want. So external port, let's put 8080. And then you get another prompt for internal port, let's put 80. And then it's going to go ahead and run the plan for you. Okay, so similar to what we saw before. So now if we want to run Terraform apply, once again, it's going to ask us for the ports. So external port 8080, internal port is 80. And do we want to proceed? Yes. And that will go ahead and create the container image and the container for us, as we've seen before, and run everything for us nicely. If we run docker ps, it will show us the container. Once again, open the container in the browser. We see welcome Nginx. Everything is good to go. Now, I want to show you another way of doing this. And what we're going to do is we're going to provide the variable assignments through the CLI itself. And the way to do that, you can run Terraform apply and use the -var keyword. And in here, you can surround your external port, let's say equals 8080. Sorry, equals 8080. Let's surround that with a single quote. And then -var again, and say internal port equals 80. In this case, I put 90. So what you'll see here, actually that's a good exercise, because now what we'll see, it's going to want to destroy something and recreate something. So that's the first time we've seen this. So plan 1 and to change nothing as to destroy 1. Because this forces a replacement in place, this will have to work, or this will have to change. Now say no, because this will break our container, because the container listens on port 80. But what we can do instead, just to show you that this will destroy the container, is let's change the external port to 8090 and leave the internal port at 80. Now that's another way of providing variables into Terraform. And now let's just say yes to deploy. That will go ahead and deploy things for us. Now you can see that we're reading port 8090 instead of port 8080. And if we look here, it's going to take a second or two to get Nginx to run. And there we go. It's running very well. And we've got that covered. So now let's go and destroy this environment. And now I'll show you a different command to destroy the environment. And this is Terraform apply with the flag destroy. So Terraform apply -destroy. It's the same as Terraform destroy. And we have to run the same thing we did before. So the external port of 8090 and our internal port equals to 80. That will run a plan. Things look good. Hit yes, and that will destroy our environment for us. And that is it for this lecture on variables. In the next lecture, we will continue looking at variables as well. Let's continue our discussion on variables. So now we are going to go into folder 04, variables continued. So let's go and change our directory to that. 04. And before we go ahead and initialize Terraform, let me show you what this folder contains. So we have our main.tf file, and here you can see the same thing we saw earlier. We have a Docker image and a Docker container resources, and we're using variables as we saw earlier, so that hasn't changed. What has changed is that we moved our variable blocks into a new file called variables.tf. If you go into variables.tf, you'll see the exact same variable blocks that were there in the main.tf file. Now we've moved them over. And there is a new file called terraform.tf vars, and here is where we're actually assigning all the variables. So you might notice that here we have some default values, but remember image name and image tag didn't have any defaults, and earlier we were defining them or assigning them through the CLI command, or we were getting a prompt. So now we can actually make all the assignments in a separate file called terraform.tf vars. And one key concept about Terraform is that it doesn't matter how many files, how many Terraform files you have in a folder, Terraform is going to merge them all together as it runs. So separating this out to multiple files is completely fine. And as you can see here, we're assigning Nginx 123.3 for the image tag. Internal port is 80, external port is 8080. I'm going to change this to 8090 just to show you that this will override the defaults that we have here for the external port. So you can suggest some defaults, but at the same time, inside of terraform.tf vars, that will override your default. Also, if you're running it through the CLI or through a prompt, that will also override the defaults as well. So let's go ahead and Terraform init this folder to get everything set up for us. And we will quickly run Terraform apply auto approve just to move faster. And here we don't need to specify anything through the CLI, and also no prompts will happen. It will go ahead and create our container image and also our container for us. And we'll see that it will generate this over port 8090, as you can see here, 8090. And let's open this in a browser, and once again, welcome to Nginx message comes up. So everything worked Very, very well. Let's go back and destroy our infrastructure. Terraform destroy auto approve. Remember, auto approve is not to be used in production. This is just for our demos here and our course. And that is it for this lecture, and I'll catch you in the next one. Okay, let's continue our course here and focus now on creating resources in AWS. All right, so we will continue here and move to our section 5. And this section we have 2 files. The first one is main.tf, which is, now you're used to it, our main Terraform configuration file. Here we're using the AWS provider and pinning it to a specific version. And this provider requires the region to be specified in the provider block. And it takes one resource because we're creating an EC2 instance. We need this AWS underscore instance keyword. We're going to give web server the name for this resource. And it requires the AMI and an instance type. Here we've hard-coded the AMI. Later we'll see how we're going to use a data block to get a particular AMI by searching for it. And we're also using the myInstanceType variable to specify T2 micro, which we'll see in just a little bit. Now there is a new block here that we're introducing called the output block. And in this case, it's the public IP. Again, this is a name that you can give it. It's arbitrary. And the value is the thing that you need to add or give the output block. And in this case, we're outputting the AWS instance. You can see here the type of the resource, dot the name of the resource, which is web server, dot an attribute. In this case, our attribute is public underscore IP. And also as a good practice to give it a description. Now, the other file, variables.tf, has 2 variables, region and myInstanceType. Region, we're going to give it the default US East 1, and T2 micro for myInstanceType. So in this case, we don't need another file, a terraform.tf vars file. We're just skipping that, giving defaults, and we should be good to go. So let's go ahead and run Terraform init. I'm already inside of my folder here, so that ran well. Now you're gonna need an AWS account for this part. So if you're part of the Techonaid subscription for the Techonaid Academy, then you can simply launch an AWS environment, and that will give you the access that you need to an account that Techonaid has, and it will give you the username, password, the access keys that you need. So you can simply grab this, which exports the environment variables that Terraform needs to run. This is the way that Terraform is going to connect to AWS's API to create this EC2 instance. Now we can run a Terraform plan, and this will again plan what we need here. Public IP will show up as an output. We're creating one resource here, which is the instance, so we can run Terraform apply, and let's auto approve this just to make it go faster, and that will create our instance for us, so we can wait on that. In the meantime, we can log into our AWS console. So let's grab this URL and grab our password and also our username right here. So let's use, this is my username and this is the new password I have. Let's sign in. And while this signs in, let's check on our resource. It's still being created. Oh, it's done. And the output gives us the public IP of this instance right here. This has been successful. Now let's see our EC2 instance. Let's go to EC2 and just verify that it is there with the same IP address. And we will be done with this lecture shortly. All right, instance is running. Let's go in here. All right, and I can see the instance that's running here, and it's the 100.26.227.178, exactly what we see here. So we've created it with Terraform, and now we can simply destroy everything as we're used to. Terraform destroy, auto approve, and that will destroy our instance for us. And again, we can verify in the console that it is terminating. Takes a couple of seconds here. And during that period, if you quickly peek here and just refresh, I guess we didn't do it fast enough. Or if you just remove instances running, you will see that this is our instance and it's shutting down right now, while it's still actually, in fact, shutting down. So you just gotta be a little bit patient and give it a few more seconds and it will be good to go. There we go. It's all done. And now we're able to create our first instance in the cloud rather than locally on our machine with Docker. Now we're using the AWS provider. And we'll continue to use it throughout the next few lectures. I'll see you in the next lecture. In this lecture, we're going to talk about data blocks. So let's get started. Now we are in lecture 6, data blocks. So make sure you're there. Let's change directory to data blocks. And now the only difference that we made, actually two things we've made. Main.tf, we now have this block called data blocks, or data block, and it's called AWS AMI. And what this does, it is a GET request that goes to the AWS API basically and gets something to be included in a resource that we want to create. So remember, resource blocks creates a resource and a data block gets something, right? So here we're going to get the AWS AMI ID, and then we're going to reference it here. Instead of hard coding the AMI or passing a variable of that AMI, what I want to do here is I want to look for the Ubuntu AMI. So what happens is I am going to use this most recent option equal to true, and I'm going to filter. So I'm going to filter on the name, and in here I'm looking for Ubuntu images, HVM SSD, Ubuntu Focal 2004, and giving it a wildcard here. Also including virtualization type HVM, with the owner being the canonical owner, and you can see more details in this article. But basically what this is going to do, it's going to return an ID for a specific AMI, the latest AMI for Ubuntu 2004, and I'm going to now reference it down here in the AWS instance resource. Notice how I'm referencing it. I'm using the data keyword here, dot the name or the type, AWS AMI, dot the name Ubuntu, dot ID to get the AMI ID, which again gets passed to the AWS instance to spin that up. Now the other change that I made here is that I moved the output to an output or outputs file here, and as I mentioned before, in Terraform it doesn't matter, you can split your configuration across multiple files. Terraform is intelligent enough to merge everything together. So really nothing changed other than moving this output into its own output file. And at a minimum, usually a good practice is to have a main.tf, a variables.tf, and an output or outputs.tf file in your configuration. You may add more things, maybe networking or storage, as your configuration grows, just to kind of split it up a bit. But at minimum, you have a main, variables, and output. So now let's go ahead and initialize our folder here. And we are going to run Terraform apply auto approve right away, just to speed things along. And this again should work fine. It will create everything we asked it to create, and it's going to reference our AMI, the data block that we used for the AMI. Let's see, you can see here data.aws.ami Ubuntu is reading, right? So it's reading, it's getting information, and it will supply this information to our instance, which is right here. So you can see it grabbed this AMI ID and fed it to the EC2 instance. And this is complete. Here's our public IP, the .155. Again, if you go into the console, you'll see that it is up and running. All is good. And that is really it for this lecture. Go ahead and destroy your infrastructure, and I will see you in the next lecture. In this lecture, we're going to see how to include another provider in our Terraform configuration. So let's get started. Now, we are in 7 another provider folder, so let's change the directory to that folder. And in here, what we've done is we've added another provider here called TLS. Notice we can add as many providers as we want. So really, you can add an AWS provider, a GCP provider, an Azure provider. Really, it doesn't matter. In this case, we want to use the TLS provider, which allows us to create a private public key pair. And then we're going to push the public key into our EC2 instance so we can SSH into it. So far we haven't been SSHing into the EC2 instance. All we were seeing is just that it got created in the console. That's about it, but really not very useful. So right here, what we did is we've added a number of resources, just 2 to be exact. First one is the TLS private key resource, and we called it MyKey. And this is using RSA as the algorithm, and the RSA bits is 4096. Then we are referencing it using this resource AWS key pair. So it's creating a key pair inside of AWS, and we're giving it a name here, and then we're giving it a the public key, which is taken from over here. TLS private key .mykey.public key open SSH is the attribute used to pass the public key over. And then in the AWS instance resource, we're doing a couple of extra things. The first one is the key name, which is this key name that we just created, AWS key pair mykey.keyname. So now we're telling the instance to use this key that we just created in AWS. And also we need to create a security group to allow SSH inbound and all the internet traffic outbound. So you can see here this VPC security group IDs is referencing this new resource AWS security group .securitygroup1 .id right here. As you can see, an ingress of everything for SSH port 22, protocol TCP, egress is everything from the EC2 instance. So let's go ahead and run this. So Terraform init as usual to initialize our folder. And from here, we are going to run a Terraform plan just to show you what's going to happen. Okay, in this case, we are getting 2 outputs, a private key and a public IP. So we need this private key to be able to SSH into the machine. Public IP we've seen before. And we're actually creating 4 resources this time, and the ones that we just went through a little bit ago. So here, this private key is sensitive. It says sensitive value, and I'll talk a little bit about what that means in just a bit. So for now, let's go ahead and apply this configuration. While that happens, let's take a quick look at our output file. And this output file has our public IP from before, but now it has our private key as well. And this keyword sensitive true means that when the output comes out, it's not going to show us that private key. And the value here is TLS private key .mykey.private key pem, as opposed to the public key pem that we saw up here, or the public key open SSH that we saw up here. Okay. Now you will see that once this gets created, I'll show you that the state file will actually still contain the private key, which is very important. It's a very important concept to understand when you're working with Terraform, that sensitive and secrets will appear in your state file. So you need to have a mechanism to secure that state file, make sure it's encrypted at rest, and have some sort of role-based access control around it to know who exactly gets access to that state file. Okay, as I mentioned before, the private key here doesn't show up. It's sensitive. The public key is right here. Let's hop into our state file really quickly to show you where the private key is. It's right here. If I do Alt-Z, you can see private key is obviously right here. We see the entire private key in the output. Also, if you scroll down as part of the resource down here, you will be able to see the public key, but also the private key as well. Okay, so that's what I wanted to show you as to how it's important to secure your state file. Okay, so now what I want to show you is that you can still even see the output. Either, like if you run Terraform output, you're going to see the exact same output that we saw here. But if you run Terraform output -raw and then you type private key, that is actually going to show you the private key as well. So once again, you need to know these things as you're working in production. Now we want to test our SSH, see if we can actually SSH into the machine. So let's do that. So the first thing you want to do is output this into a file. So Terraform output raw private key, and let's put this in a mykey.pem file. So that should show up right here. So now our private key is stored here. The next step is to change the permissions on this file, because right now it's too permissive, so we got to tighten it up a bit. And now finally we can run the SSH command and use the -i flag to use the key file that we just created. And also I'll show you how this is a trick where you can use just typical bash to run the Terraform output raw public IP to output this into this command. So the output of this command is going to get replaced here. So you can you can SSH with username Ubuntu at this IP address of the output. So with that done, we can say yes, and now we are SSHing into that machine, and sure enough, we are in the machine here, as you can see. And also, if you check the console, you can see our console here. Here's the 3.94.211.74. So that worked as expected, and that is pretty much it for this lecture. Just make sure that you exit here and destroy the infrastructure, and I will see you in the next lecture. In this lecture, we're going to discuss the topic of modules. Let's get started. Alright, so we are in the 08 folder, modules, so let's make sure we're there, and I believe we are. Perfect. And now we're going to talk about modules, and we kind of talked about this before, but we're going to dig a little bit deeper here. And the concept of modules is to basically reuse code. So you might be a DevOps engineer or platform engineer responsible for creating those modules that they can be consumed by developers or by application teams and so on. So what you want to do is create some sort of abstraction sometimes, so you can put a few resources in a module and create specific things for your organization, specific resources that you need to provision. You can version control modules, of course, and you can create different versions of them and so on. For today's demo, we're just going to create a module based on one resource, which you typically wouldn't do. You probably would use more than one resource in a module, but just for explaining purposes, we are going to take our TLS resource that we saw before, and we're going to put it in a new module. So right here, this is called the root module, where we have our main.tf, outputs.tf, and variables.tf files. And then there is a directory here called modules, and inside of modules we have our TLS module, or all the other modules that you might include. And inside of the module, as a best practice, is to have at least 5 files. A license file, a README file explaining how to use this module, and a main, an outputs, and a variables file as well. Of course, you can add more if you need to, but at minimum you would have these files. Okay, so let's go ahead and take a look at our root module, and this root module calls on the TLS child module, and we'll see how that works. In here we have our AWS and TLS providers, and we've got our data block. We've got some resource blocks we saw before, the AWS key pair, the AWS instance security group. Then there's a new block here called module. And here's where we're calling our child module TLS. The source in this case is local to our folder structure, so it's calling modules TLS. You may use a source that calls upon a module in a private module registry, for example, in maybe Terraform Cloud or any other provider, or it could be a public module that you would reference as well. In here, we're passing some variables into the module. So the algorithm is RSA, and the RSA bits is 4096. So that goes into the module, these variables. And these variables can be also defined at the variables level of the root module. So we can pass a variable from here. All you do is just say algorithm equals var.algorithm, for example, and that will take the variable from the root module and pass it down to the child module. Now, we can access outputs from module as well, and actually we're doing that right here with the public key that we're going to use with our AWS key pair resource. And the way to do that is you call on the module using module keyword dot the name of the module TLS dot the actual output that the module is giving us, which we'll see shortly. Furthermore, in the outputs file, we can output from the module and back out to the root module. In this case, we've seen public IP, that's straightforward, but the private key is actually taken from the module.tls the private key output that comes from the module itself. So the flow of data comes from the module, the TLS module, out to the root module, out to the user. So now let's go into the actual main.tf file inside of the module TLS. And you can see all we did is we've taken the resource TLS private key and put it in here. And this algorithm RSA bits are looking for variables algorithm RSA bits, which we define here. Similar to what we do in root modules, nothing has changed really. Same syntax, so variables are defined here. And then finally the outputs that I told you is coming out of the module going out to the root module. We've got two of them, private key out and public key out. And you can see the values are taken directly from the resource within the module, and those are passed out to the root module. So that is pretty much what a module looks like, how you can create a module. Of course, you can consume modules from other folks in the public registry, or maybe again internally. If you have an internal private registry, you can consume those modules as well. But it's helpful to create a module yourself so you can know how to utilize others' modules. Okay, so let's go ahead and Terraform init. And we're doing Terraform init at the root module, okay? And as you can see, during the initialization process, Terraform sees the TLS module in modules.tls. So that has registered with Terraform. Now let's run Terraform plan. Make sure everything checks out. Looks good to me. And now let's just run Terraform apply, and let's auto approve that. And once that's complete, let's go ahead and double check by SSHing into our EC2 instance that we just created or are creating to make sure that the TLS resource that we put into the module is working and everything is good to go. I'm going to pause the recording. It might take a few seconds here and come back to it. All right, it's successful. So let's go and take a look at the console here. So we see the .189 and the .189. Everything looks good. And let's use the same commands that I showed you in a previous lecture. So we're going to grab the output from Terraform and we're going to store it in a new file called mykey.pem. And now let's change the permissions on that file. And finally, let's SSH into that machine. Okay, looks good. Excellent. So we're able to SSH into the machine, no problem. So that is pretty much it for this lecture. I hope you learned something new and enjoyed it. and I will catch you in the next lecture. You've made it to the final lecture, and in this lecture we're going to put everything together that we've learned so far to create a web server inside of EC2, inside of an EC2 instance in AWS. Why don't we get started? All right, so now we are in folder 09 A Web Server, so let's go there. And here what we have is we've got our main.tf file, and I will just show you what is new here. And all that's new are these two lines, the user data and user data replace on change. And this user data is actually referencing a file called install_libraries.sh. It's a shell script, and we're using the file function to call that. And if you're familiar with user data, it is a way for a new machine that comes up in AWS. In most cloud environments has that, and these cloud environments will give you that option to run a script on launching of one of their instances to run whatever you want in that script. And in this case, we're going to run the install libraries sh script, which will update apt and install tree, install nginx. And in nginx, we're going to put an HTML body here, and just in our index.html file, that is the default that nginx is going to render for us, and we're going to reload nginx, and then we're going to see our website up and running. So really that's all that I wanted to show you here, and it's quite simple to do with Terraform, just using this user data option in the AWS instance. And we've pretty much captured everything we've seen before in the previous lectures. So the outputs, we're going to see our public IP, our variables are here as well, and we also included one more thing before I forget. In the security group, we've now added our HTTP ports to the ingress so that we can access the web server on port 80. And that's it. So let's go ahead and run this. Terraform init. And I'll run a Terraform plan. Everything looks good. Let's run Terraform. Apply. Auto. Approve. And it's going to go ahead and deploy this for us. It'll take a couple of seconds, so I will pause the video and we'll come back after. Alright, so it has completed successfully. And let's go and take a look at our new website. So let's copy the public IP, open a new tab, paste that in there, and there we go. Here's our web server. Nice shiny web server with nginx running. We have a picture, we have a bunch of really cool stuff going on here. So that is pretty much it for this Terraform course. Make sure you go and destroy the infrastructure once you create it. You don't want it to go on running. And I hope you learned how to use Terraform and why use Terraform and the whole point of infrastructure as code. And you saw some examples. We talked about Docker in a local environment and also how to run EC2 instance in AWS in a cloud. So go ahead, test it, run with it, ask questions. If you have questions, put them in the description of this video. Let me know what you think of this video, and I will catch you in another video.